Welcome, everybody. This video will focus on the lecture topics for Unit 7, where we start to talk about data types. Now, can I just do a quick poll here in the room and those in the Zoom session here? I know the answer, I think, for most of you, right? All three of you have either taken Python or are taking it right now, right? You're taking it too? Okay. And I think, I'm not sure if Teofilo online is doing it, but so you guys are getting the concept of coding. And as you learn how to code, right, and I'll use Python as kind of our reference language because that's the one that most of you are probably studying. We start to talk about data types when we talk about a regular programming language, right? Like, what are the different data types in Python, for example? You guys remember? Remember, it's not this isn't your midterm exam, right? But how about like integers, right? That's a data type. Floating point numbers and strings. Those are like the three primary data types of Python. Truth be told, it has many more, but those are the ones that most normal humans use. Right? And then you take those data types and you build upon them to create other data types. And in some languages, all right, Python is not one of those languages. Python is a language that is what we say is not strongly typed, meaning that if I have a variable where I'm storing, let's say, a number, and then 5 minutes later I just decide to store text inside of it, it works, right? Python allows for that, which is very atypical for programming. If you were in a traditional programming language, let's say like Java or C#, then you would have to declare your data type. So I can't put words into an integer data type. And the reason I bring this up is that's how SQL works. SQL is very strongly typed, and it has a number of different data types for storing information. Think of the ones that we've used so far in writing our SQL code, right? So if you want to store like a name, what do you use? Varchar, right? And a size, right? Or we have used int for integers. We've used, I think, either decimals or doubles for floating point numbers. And then, of course, the text ones can be really big, but there's also a bunch of different ones that we haven't even been introduced to yet. What's another one we use? How about date or date time? You guys remember that? And I think that's most of what we've used so far. And maybe we've done maybe one with character where it was like 2 characters long or something like that. In reality, whenever we put information into a database table, every column in a database is strongly typed. The only thing that can go in that column is something of the same data type. So if I go ahead and just bring up MySQL Workbench here, and I'm just going to load up a database. I'm not really sure which one. I'm just going to bring up, I don't know, the customer table. Let's just take a look at the customer table in the My Guitar Shop database, right? And this is data that we've been looking at before. And by the way, these email addresses are fictitious. And if you guys are wondering why I'm saying that, YouTube has this tendency when I post stuff out there to block it because they see the email addresses and think they're real. These are not real. These are not real passwords. This is fictitious for educational purposes only. And I'm saying all this to circumvent the filters on YouTube that might otherwise block my content. But we can look at this table, right? And we can identify that all the customer IDs seem to be integers. The email addresses are text, and I don't know if they have an email data type, but they might, right? There's a password field that seems to be text, integer. And if I tried to insert a different value, let's say here, with, let's say, letters in it, it just would give me an error message and it wouldn't happen. So here's kind of this weird connection. When you learn how to code in a programming language and then you learn databases, One of the reasons we have to be really specific in the programming languages about our data type is because if we write an advanced application and we try to store the information from the application, where does it end up? In a database. Databases have strongly typed data types, and that puts a responsibility on the programmer to make sure that the data that's being sent from the application is the right kind of data type that's going to the database. So, like, why is it you go to a website and they say, enter your phone number, right? And have you ever gotten this, right? Where it's like, oh, that's not a number. I was like, well, hold on a second. I put dashes in there. We talked about this, right? I put dashes in there, so they only want numbers. So they have to either write code to fix it, or they have to strongly type their data on the inbound too. So like, because our information ultimately gets stored in databases, it becomes really important on the front end. The systems that feed in the data have to deliver the information in the correct format. So, and I want you to think about this. Most people use apps to feed information into a database. Then it's up to the app to tell the user their data is in the wrong format because the database is rejecting it, but they don't get to see the database error messages. Just the database admins see those. See the little conundrum there. So it's important to kind of note those things as you learn about data types, that you need to have data in a certain format, even in a programming language, just so that you can get it into the database correctly. There's, and I say this here in the course show, in MySQL, there are three main data types. Now, this sounds a little Python-like, right? But in Python, what do we have? Integers, floating point, and strings. Here we have strings, numbers, numeric, and date time. That's not all, though. Those are the three main types, right? So we're going to kind of learn about all those three main types, and then we'll learn about some weird ones that go with it. Now, it is important to note that as I'm creating this video, that in the fall semester of 2025, we are using MySQL version 8, right? That's the base version of MySQL that we're using. So the information provided here in the video is based upon that version. That does imply that if you use older versions of MySQL, that some of the data types might not be the same. And here's, don't freak out to that, right? Because the truth is you have to go way back for them to be significantly different. And they've been pretty stable for a long time, at least as far as I know. Notice like their first little blurb here. It says the data type of a column defines what value the column can hold: integer, a character, money, date, time, binary, and so on. And I think this gets really interesting, especially when we start to cross over into the binary areas, and we'll talk about what that means. But let's start with the real basics here, right? So every time we create a table with SQL code, one of the things that we have to do, if you remember, is to create a data type with it. So if I say first name is my field name, I might assign it like a var maybe of size 20 or 30 or something like that. And then I can also declare it can be not null, can't be empty. And then I could make it a primary key or a foreign key or something like that, right? But we still have to decide on what data gets in there. And therefore, once that's defined, you cannot put anything other than that into that container. Just as simple as that. There are the three main types, and I'm going to start scrolling through these here. I might go out one click on Zoom. We'll look first at the string data types. There are a bunch of these, by the way, and there's some that we kind of very regularly use and some that we kind of don't, but they're there, right? And some of those are either legacy ones or they're new ones that a lot of people don't know how to utilize yet. The primary one that we use for text is varchar, right? And that's how I say it. I'm not sure if that's correct, by the way, but I've heard other database people say it that way too, so I'm assuming I'm okay, right? And notice this is a data type that allows for a variable length of string. Now, if you compare that, let's say, to Python, if you throw a string in a variable, I can make that string as long as I want. It can be like a word, or it can be like a novel. And Python will just take it and go, okay, fine, thanks. Right. Um, I want you to notice here, though, that there's a limit to how big a varchar can be. And this is kind of one of the reasons we're talking about this stuff. So it can go from, the size can be from 0 to 65,535, right? Um, and that's not an accidental number. That's based on a power of 2, right? But would start counting at 0, but you would add 1 to the 65,000 number. But that is your maximum size. So with a varchar, you're looking at like 65,500 words, or excuse me, characters. You should be careful about that. Each letter is a character that you can fit inside of it, and you can size it. Now, you don't have to include the size piece, and this is kind of interesting. If I don't declare the size, what size is it? Would you guess? Full size. This is the answer, right? It would just give you all of that space. But if you're only entering, let's say, like the 2-digit like state abbreviations, does it make sense to leave it full size? No, because every time you're storing that record, you're wasting 65,533 character spaces each time, which makes no sense. So one thing we do is, if we know what size the data is going to be roughly, we give it a size, because then it utilizes memory more efficiently. Now, prior to having varchar, we used to use the character data field as our primary one. And I want you to notice that that one, if I don't declare a size, and it says right here, the default size is 1 character. This one doesn't declare what the default is, but I will tell you it is a full size. The character one is a fixed length string. So think about this. If I declare it to be 255 characters and I don't use 255 characters, it will occupy that always. A varchar, right? And I don't know how flexible and dynamic these are. In principle, is variable length. So even if I declare, let's say, a size of 20 and I only use 5 characters, it's going to find a way to try to recoup the other 15 characters worth of space and use it somewhere else. I've heard mixed things from database admins saying that it doesn't really do that. Some of them insist, no, it does do that. And I think it depends on what database system you're using. But in principle, using varchar is generally better, because it supposedly dynamically adjusts, and therefore space that normally would be wasted is reallocated back to the system to use somewhere else. Right. One really interesting thing that people don't know about database entries, like every time we add a record to a database, the moment the insert command happens, or let's say like you're using an app and you hit submit or whatever, it goes into the database. It's written into the database already. It's not like I have to save the file like it's a Word document or something in order to not lose the changes. The moment the information's in the database, it's written to the hard drive that the database is sitting on instantaneously, record by record. It writes it 1 record at a time. So I think that's pretty interesting. I want you to notice some of the rest of these string data types. So for example, and I'm kind of going to skip around here a little bit. I'm not following the order exactly as presented. We also have text, right? So this is kind of an old data type too. And notice its capacity is, you guys notice how many bytes it is? But if you compare it to this represents characters. This represents bytes. Is there a difference? And you guys are like, okay, you didn't really teach us about bits and bytes, or right? And by the way, like if you guys ever formally study computer science as a discipline, they go into this whole thing, right? Like a bit is 1 binary piece of information, like a 1 or a 0, right? A byte is 8 pieces of information. By the way, it takes 8 pieces of information to declare all the characters on the keyboard. So a byte is in essence a character. So it's the same size as a varchar. So you could use text as a data type for storing text. So I think this is kind of an interesting thing. Notice that we have tiny text, which relates, by the way, to character. Right, so these are the older versions. We have blob, and binary large objects holds up to 65,535. It sounds like we're hitting on the same number a lot, right? But so you notice that there's like these different formats. So we got blob, we got tiny blob, right? Then we have medium text, and I want you to notice like medium text. All right, now we're getting some more characters, 16 million characters, right? I don't know if that's enough for a novel, but that's more respectable in size. There's also a medium blob, which happens to be the same amount. Then we have long text, which takes it up to, I guess that would be 4.2 trillion characters. I'm thinking you could probably get a novel in there, right? And the same with a blob. And you notice how like some of these have overlapping values. So they're kind of functionally the same. So that covers most of these, right? And binary, by the way, is kind of the equivalent of this. But I think the difference when you're looking at any of these that are binary, right? And here's the primary difference. It doesn't actually store the character. It stores the binary representation of the character, which was a collection of ones and zeros. All right, so then you're going to go, like, why would you do that? Right? It's just a different way to store the information. Ultimately, it still becomes binary on the hard drive and in memory, but it's stored in a different format. There's two others that can store strings, and these are what we call sets and enumerations. But these two basically can store collections of values. So if you could imagine an enumeration, a really classical use of an enumeration is that, let's go back to that thought of like, I'm doing like city, state, zip, and I want to store all the 2-letter state definitions for the US. I can put those in the enumeration, and that one entity or column and entry would hold all the state definitions in one spot, right? And it allows up to 65,000 values in there. A set is similar, but you can list up to 64 values in the set. So maybe this one would probably be better actually for storing the states because we only have 50, right? That would be a more efficient usage. These are not ones that we're going to play with here, but these are concepts that are basically data structures. So one entry in the database can hold a complex object, is kind of where this leads to. Right. The next category are the numeric data types. And like strings, there are more than a couple, right? This is not Python, right, where we have integer and floats. And if you do know languages like Java or C#, and the ones that we teach here on campus a lot, those do have kind of the same data types. They have integers, decimals and doubles, and then you have like large ints, small ints, binary, etc. So a lot of the same stuff is replicated here. But there's many different types, and this is an area, once again, that programmers usually don't use a lot of variance when they're creating databases, and I just put that out there. The most common ones that we use are int, right? And we've used this quite a bit already. Very, very common to use. The other one that we use a lot is either double or decimal, right? And those are somewhat interchangeable. We'll look at each one of these and kind of expand from there. But let's start with int, and then notice that they also include the old-fashioned version of it, which is just to say integer, but it's basically the same data type. And an int is actually a medium integer, right? It has a signed range, so I can go from negative, whatever that is, to positive, whatever that is. And I think that's like 2 trillion, right? So, or if I don't have positive and negative signs, I can go up to 4.2 trillion. You can declare a size for integer, but I want you to think about this. So far, when we've declared integers, have we declared a size? No, we haven't, right? And very, very typically, we don't. We just say, oh, we're just throwing integers in there, whatever, right? Um, and I want you to notice what the size actually does. It actually only controls what we display on the screen, not what the actual size of the number is. And what this is saying is that at maximum, we can set it to display 255 characters. And if you think about the numbers that it holds, you would never need to use that. So the size is only used for display, not for what goes inside of it. The capacity is predetermined by the data type, and it's either that or that. So int is kind of the same as integer. Well, not kind of the same, they are the same. But we also have small ints. So notice much smaller number range, right? What's the advantage? Less memory usage, right? How many programmers do it? Very few. Everybody just uses integer and rolls with it. Medium int, same thing, a slightly expanded data range. Either negative to positive or 0 to a positive number. And then you get up to int, and then if there's a small, medium size int, you can imagine there's big ints also. So they have a thing called big int, and look how big those numbers get. Those are huge. That's probably where they store our national debt. is in a big int because it's so huge. So notice how many of those are just integers in different formats. Does it make sense to use specific integer types depending on what the size of the numbers that you're storing? And I would say yes, it does make a difference, especially when you're doing calculations and you have a really, really large database. Being efficient with the memory usage and the size of your data types can make a big difference on performance and speed. We kind of have cast that away in modern times because we have so much storage available to us and we have so much speed, but there was a time when these were really big concerns for programmers. We also have floating point numbers, right? And I want you to notice that these will have this designation where we can declare the size. So that would be the total number of digits in the number. And then the D, the second parameter, would indicate how many digits after the decimal point can be stored, right? So if you're doing scientific stuff, you want a lot of decimal places, right? If you're calculating money, how many decimal places do you need? Right, just 2, in principle, at least. The ones that we tend to use more for floating point numbers in MySQL are these 2, the double and the decimal. And I want you to notice that the double is considered the quote unquote normal size floating point number, whatever the heck that means. They don't really tell you how big that is, but it says the total number of digits is specified in the size, number of digits after the decimal place is the D, right? So there's also double precision, which is basically the same data type as the one above. So I don't think you normally see people using this one. And then decimal is very similar to a double also, but it's an exact fixed point number. The total number of digits is specified in the size. So it's a precise number that gets stored in there. The maximum number for size for this one is 65, and the maximum decimal places is 30. Right, so you can go up to that. So the biggest you could make this is a 6530. But the default value is 10, and the default value for the decimal place is 0. So You see this one a lot. Decimal is used a lot for doing money, right? Because think about this. In money, we always have two decimal places after, the decimal point, right? And if you're doing certain types of calculations, the size on the other side of the decimal point is usually pretty fixed as well. So very, very common for financial usage. Now I'm going to scroll up to the top and talk about these other ones. We had the small, medium, int, regular int, big int. Did you notice that there's a tiny int too? This one is just for numbers that range 256 possible values, -128 to +127, or 0 to 255. So this one I do see used quite a bit when we know the numbers are going to be small. That's pretty common. We also have a bit, which stores basically, a bit value type, as it says. The number of bits per value is specified in size, and the size parameter can hold a value from 1 to 64. And why 64? Because it's a power of 2. The default value for the size is 1. And normally so in other words, we're storing one number. And maybe that's okay for some things. I'm not thinking of a scenario in my head right now where that would be used, but maybe dice rolls or something like that, right? We only need one character to represent a dice roll, right? Because it's going to be 1 through 6. The other one that we're looking at is the Boolean data value. And normally in a programming language, and I think we've started talking about this in the Python class, those that are taking it this semester, a Boolean value is basically true or false. But in SQL, they don't store the keyword true and false like we do in Python or Java or C#, right? What they do is they store 0 as a false value, and I want you to be really careful on this. Non-zero values are considered true. So it's not 0 and 1. It's 0, and anything else you throw in there is true. But they don't store the keyword true or false like we do in Python. They store 0 for false and anything else for true. So normally, and like I said, in most other programming languages, that's considered a separate type of data. All right. The other real common one that we have here is working with date and time data types. We've played with a few of these already, and I think we may have even looked at some of this date time information. And one thing I always want you to remember here is that the date formats are year, month, day, right? And we've talked about the why behind that. And they support dates from the year 1000 through the year 9999. I think it's kind of interesting. Like, why don't they roll it all the way back to 0? Or why do we have to go that far into the future? And I really don't know the answer to that. Somebody just arbitrarily decided that for some reason. Right. So that's kind of interesting. When we throw in date time, that also includes a timestamp in the mix. So we get the year, month, day, and then we get hours, minutes, seconds. And I want you to notice 24-hour clock, right? Because there's no designator for AM or PM. That's extrapolated. Yeah, so this is kind of interesting. This type of field, and this is true for many of them, is you can trigger them to automatically timestamp. And we do have a separate one that is a timestamp. But if you add this as being default and on update, anytime the record changes, you can have the timestamp update. And this is kind of a common thing database people do. Like, okay, well, you changed your address. When did you change the address? Oh, you changed it on, right? And it gets timestamped right into the record. So that's kind of an interesting thing. You can actually formally declare a timestamp. So you can write it into your code. So like every time, like let's say an order gets placed, it timestamps it. Like, when did the order come in? Okay, it came in on Friday at 2 o'clock, And you can imagine that's pretty useful information. Um, and yeah, and basically they're still using the same formatting. So year, month, day, hour, minute, second. If you wish, you can just store time. Notice with the time format, you can exceed the number of hours. You can go negative hours and positive hours. I'm not really sure what the functionality of that is, but there might be times that you're measuring time. And then you can also just store the year, right? And some people will say, oh, I could just store the year as an integer. No, but it's treated as a different data type in a database, by the way. Yeah. And notice MySQL 8.0 does not support year in two-digit format. And this is a like weird thing to talk about, but when I was graduating school and getting out into the workplace, a few years after I was out in the job market, Y2K happened. And all the old, not all the old, some of the old database systems were written with 2-year dates. And then they're like, oh, I guess we should have done 4, right? And there was a lot of work at the time updating database systems to a 4-digit format. And then after that, I think they got a little bit wise to it. Now, the other thing I'm going to do here is I am going to go to this second link to look at the MySQL tutorial website. But I also want to kind of point out that on like right inside the unit folder here, I kind of included this table. And I'd say that this table is probably a good listing of data types that we use pretty often that are character or numeric, right? So these are the ones we tend to use. And I think it's a handy little chart, so you can take that for whatever you will. Let's go up here and take a really quick look at the data types as they're defined on this website. And I want to show you that there are some that aren't listed where we were looking before. So here's kind of the string data types. And what I do like about this is, I guess this listing is maybe a little bit more efficient, right? So we have all the string data types here, number data types, right? They go through and they talk about all these one by one. The Boolean data type here, they're listing it not with numbers. W3 lists it with the numbers for whatever reason. Then we have our string data types, right? And there's like readings attached to each one of these. The date and time data types, right? Same ones we just looked at. And then we get into some of the newer, weirder ones that have been added. I'm not sure exactly when most of these came in, but I want you to think about this. So you're cruising around, you got the GPS going on your phone, or you got a Garmin in the car or something like that, and your location data is being tracked on your phone, right? They came up with data types that they call spatial data types that can store this type of information. This is nothing we'll use in this class, by the way. I just want to make you aware of the fact that it's out there, where you can declare geometry, points, line string, polygons, et cetera, et cetera, et cetera. And these are all things that you can store in a database. And you can imagine these are highly specific types of data. They're probably numeric, and they're really basically vectors or something like that. You can also store JSON. So JSON, by the way, is a data transmission format that's plain text. That's called JavaScript object notation. And we haven't learned about this in the Python class yet, but it's basically what we call key value pairs. Inside of curly brackets with semicolons and colons separating the data, and it's all comma separated. But it's a very, very common transmission format for sending information across the internet from app to app or database to database or what have you. And it's used so much that now they've set up a data type for it that holds that kind of information. So if you receive that kind of information, you can just natively store it, and then you can use it to transmit or whatever. But it's out there, so that's pretty interesting. Okay, I think that covers all the weird ones. Now, we can also, in some clever ways, store other types of things in databases too. Um, but usually it's by converting things to binary formats, and that's why we have number formats that hold binary information. So for example, if I stored binary information, I could take an image and store it in the database. An image normally is not allowed to be stored, but if I convert it to binary data, I can do that. All right, let's then take a break. We're about an hour in here. We've talked about, I think, all the major stuff. Actually, no, there's a couple things. Um, yeah, I'm actually going to click through to these two functions. Let's read up on these because we're going to use these during the homework. And this one we're going to use quite a bit, the cast function. So I apologize. I thought I was done, but I had two more topics to go. So the cast function is a function where I can take one type of information and then convert it to a different type of information so that it can be stored in a database. I want you to think about this. If I had a user tell me their date of birth, right, and they might type that in on the keyboard, or maybe they use a web application where there's little drop-down boxes, and the result of that web application is to give me a snippet of text. But that's not a date format. That's the correct way to list it as a date format, right? But it's still not a date. So I can use the cast function and it actually turns it into a date that the database recognizes as a separate data type. Now, this is pretty fascinating that you can do that. I'm not going to do the demo on it. There's different things that you can cast, right? So the one thing that you can cast to is a date, but you can also cast to all of these other types too. And I want you just to look at that list there. So for example, I could take this number right here and cast it as a character. This one might be kind of interesting to look at. So if I run this code, it's not going to give you what you necessarily think. But now it's casting this as a character. So now it's really a string in memory. It's no longer a number. Right? How do we know? This is a number because there's no quotes around it. But now it's coming back on the screen and it really does have double quotes around it now that it's making it through the screen. So that's pretty common to take numbers, make them text, or take text and turn them into numbers, right? Here's one where we're converting time. This one's probably worth doing too, right? So is that to be expected to be a mathematical equation? You know, that's a question you should ask yourself. Right? And well, yeah, and that's exactly what it is. What happens if I take 5 and subtract 10 from it, it becomes -5, which is a signed value. So this is one of these casting techniques. If I want to store a negative number, often we have to sign it to make it store. I think that kind of covers it. The rest of the casting stuff I'll show you as we kind of get rolling. Let's go back now and talk about the if function. And for those of you, hot on the heels of talking about this in the Python class, this should be kind of conceptually a little more clear for you than if you hadn't had that, instruction first. But basically, when we do an if statement inside of any sort of coding language, we're checking a condition for true and false. And then we have what happens if it's true and what happens if it's false. And if you look at how this is laid out here, right? This is what we're checking to be true or not. Is 500 less than 1,000? And then what are you putting? What's the result of that if it's true? What's the result of it if it's false? So like for this one, if I come here and run it, right, is 500 less than 1,000? It is. So the output is yes. This is the true response. All right, but what if I change the code? Right? What if I add a 1 in front of that and run it? And now it says no, because 1,500 is not less than 1,000. That's false. So then it does whatever the false thing is. document. We're going to use this for one of the exercises today, which is why I'm talking about it. All right, let's cap the lecture here and do a 5-minute break, and I'll come back with a fresh video for the exercises.